Today's subject is Kubernetes networking that plays a crucial role in ensuring a smooth communication between containers, services, and external resources. In this video, we will explore the different type of networking in Kubernetes, how it works, and provide a step-by-step instruction to set it up effectively. So Kubernetes networking provide an infrastructure needed for communication within the cluster. Unlike traditional network setup, Kubernetes uses a flat networking model where every pod gets its own unique IP address, making the communication between the pod seamless. Um, Key components in the network Kubernetes, we have the pod IP, so every pod gets a unique IP address within the cluster, enabling direct communication with other pods. A service IP that is stable, that provide a stable endpoints for accessing pods, abstracting the underlying dynamic IP of the pods. Domain name server, a DNS, so Kubernetes automatically assign a DNS name to server, simplifying the discovery process. Kubernetes offers various network types based on different communication needs. So here's a breakdown of the 4 different types that Kubernetes offer, starting with the container-to-container communication. So this is like an internal communication within a pod. One of the use cases is a container within the same pod communicate over localhost since they share the same network namespace. Pod to pod communication. So this is a cross pod communication within or across nodes. For the use case, so each pod gets its own IP, allowing them to communicate directly without the use of NAT. Service communication. Pod communicates via Kubernetes services. For the use case, pods use services to find and communicate with other pods in the cluster, especially for load balancing. And finally, external to service communication. So this is a traffic entering the cluster from outside. And for the use case, the services exposed via node port, load balancer, or Ingress enable external clients to access application running in the cluster. All right, so let's start doing the setup and manage networking in Kubernetes cluster. The first step is always set up the Kubernetes cluster. All right, so we start by doing the setup for the Kubernetes cluster, and the most straightforward approach is to install Minikube. The installation is very easy to do. You just need to go to the official documentation, select your operating system, and just download Minikube. Make sure to have Docker Desktop installed here. Yeah, so we'll just start Minikube dash driver Docker. Alright, so just to confirm that everything is running correctly. So yeah, this looks awesome. Um, Kubernetes uses a container network interface (CNI) plugins to manage network connectivity. So here is a few popular options. We have Calico for networking and security policies, Flannel, a basic networking option for small clusters, and Wave provides an easy setup with built-in encryption. Okay, so since we have Minikube running here, the first thing we will do is to install the CNI plugin. So for this demo, I will install Calico. So we just need kubectl apply -f, and I will grab the official YAML file from the manifest and just apply it. And yeah, the Calico kube controls is created. Just to confirm, git -a, and we have it here. Awesome. Okay. Right, so after installing the CNI plugin, right now we need to verify the pod-to-pod communication. All right now we have to verify the pod-to-pod communication. I will run two test pods. So kubectl run test one with an image equal nginx. Okay, dash dash restart. Never. So this is my first pod. The second pod would be test2 with the same image. Okay, kubectl get pods, and we have two pods running. So we will need to exec in one of the container pod, and just to confirm that we have connection by pinging from the first pod to the second pod. All right, so we'll do kubectl exec dash it test1 dash dash and to access to the shell. So I have ls here. Let me see if we have ping. Okay, we don't have ping. We have to install the ping utility. We'll probably do apt get update dash y. Okay, and then apt get install dash y IP utils ping. Okay, this is we have ping available. So I need to grab. So this is the shell of the first pod test one. I will need to grab the second pod IP. So kubectl get pods. Okay, test2. Okay, kubectl describe pod test2. And we need to grab the IP, which is over here. And I will just do a ping. And yeah, as you can see, it's working. There's a connectivity between the two pods. So we'll exit this one. And yeah. So with that test being done, right now we need to create and test the servers, Kubernetes servers. All right now we will create and test a servers. So I'll create a new folder, network, cd, network. We'll open this with VS Code. Okay, we have this. Okay, so I will create a new file, service.yaml. Define API version v1, the kind is service, metadata, name equal my service. For the spec, we'll have a selector, app would be test1, ports, protocol equal TCP, and port equal 80, target port would be 82, and the type would be cluster IP. Alright, so with that being done, we will need to apply this. So kubectl apply -f service, and this is created get svc. Okay, it's created over here. Alright, let's move on to the next step. So moving on to the next step, which is enable external access using Ingress. Alright, so to enable external access using Ingress, we have to install nginx ingress controller. And to do this, we need to do kubectl apply -f, and I will grab the address for the official YAML documentation. I will include all of these commands in the GitHub repository. Okay, so kubectl get pods -a. Alright, it's still not running here. Alright. Okay, this is being run. This is running. Okay, awesome. Alright, let's right now let's configure the Ingress resource to route traffic, and we will open our VS Code, create a new file, ingress.yaml. So we'll have API version networking, and kind would be Ingress. So metadata, name be my Ingress, spec. We have rules here. Host my app.example.com. HTTP path, and the path would be slash path type. It's a prefix. Backend service. So it would be my service. This is the same name as the service that we created, and we have a port here would be a number of 80. All right. Okay, so right now let's apply this ingress by doing kubectl apply -f ingress, and our ingress is created over here. All right, kubectl get ingress. Yeah, it's created. With that all being done, the last step is to implement a network policies for our Kubernetes network. All right, so the last step to do is to implement a network policy. So to control traffic flow between pods, use a network policy, and this really helps to enforce security and ensures only authorized pods can communicate with each other. So we will create another file here, would be network policy.yaml. And API version would be networking Kubernetes v1 network policy, and yeah, we'll start defining the metadata. Name would be allow engines. Spec, we have a pod selector, and we need to match labels, app engines, and yeah, policy types, ingress and egress. All right, so for ingress, from pod selector, for example, we have match labels here. For the role would be, for example, front end. Okay, egress to pod selector match labels, and the role would be here backend. All right. So okay, to pod selector. All right, this looks good, and we will probably do an apply for the network policy. Apply -f network policy. Okay, I have a indentation error here. Just gonna fix it. All right. So the network policy is created, and just to confirm that it's available network policy, it's over here. Awesome. All right. This is it. So there's a few different tools for Kubernetes network. So one of the best tools is Cilium. So that offer cloud native networking and security, especially suited for large cluster. We have Kuberouter, which is a lightweight networking solution with a built-in routing, firewall, and network policies. And SEO, which is a service mesh for more advanced networking features such as traffic management and observability. Overall, Kubernetes network forms the foundation of any cluster, ensuring seamless communication between services, pods, and external entities. By understanding the type of networking available and following the step by step, such as installing the CNI plugins, configuring services, and setting up the network policies, you can create a robust and scalable network for your application. And that's it. Thank you for your attention.